May-June 2024, Paper 6, Variant 1, Alternative to Practical. A student carries out a titration to find the concentration of a sample of dilute HCl. The student adds 25 centimeter cube of aqueous potassium hydroxide to the apparatus labeled A. He then adds a few drops of a suitable indicator to the apparatus labeled A. Uses a burette to add HCl to the aqueous potassium hydroxide and indicator mixture in the apparatus labeled A. Name A and B. So A, we have a conical flask, and B, we have a pipette, or you can also call it a volumetric pipette. Why? Because pipettes measure accurate values, for example 25 centimeter cube exact and 50 centimeter cube exact, and so on. The student adds the indicator after the volume of the 25 centimeter cube of aqueous potassium hydroxide has been measured. Explain why the student adds an indicator to the aqueous potassium hydroxide. He adds that to determine the point of neutralization when the acid and alkali react with each other completely to form a salt. And name a suitable indicator. We can't use the universal indicator because its color is always varying, like from the spectrum of red to lilac. So we're gonna use either phenolphthalein or thymophthalene. Phenolphthalein will be colorless in acid and will turn pink in alkali, presence of an alkali, and thymophthalene will be colorless in acid and blue in alkali. We can check our answers over here. So conical flask, pipette, so it can change color at the end point. And methyl orange or thymophthalene. Methyl orange is gonna be orange in an alkali and reddish, darker red in acid. Describe how the student can determine the volume of HCl used in this titration. He can use a burette, and basically he can keep on adding some HCl into the already present potassium hydroxide in the conical flask and note down the volume at which the color change takes place. Let's check. Take the initial and final burette readings. Final minus bro. Okay, never mind. Mine was correct, but he meant describe how a student can determine the volume of dilute HCl used in this titration. He can I think he's already mentioned this. I believe. Describe how the student can determine the volume of dilute HCl used in this titration. He can final minus initial and then use that value. I hope you guys understood this. This examiner said, take initial and final burette readings, and final readings minus initial readings is gonna tell you the quantity of the volume of HCl used. Okay, so now we have part D. The student observes the color change that occurs as they add dilute HCl from the burette. Observe the color change that occurs. State one other thing that the student should do as they add the dilute HCl to the aqueous. He should mix it, shouldn't he? Wait, where's butterfly? Yeah, he should mix the contents of A. He should obviously mix it, because if he did not mix it, he could not fully observe the color change. It would be really cloudy in some regions, like concentrated colored clouds, if you get what I mean. Question 2. A student investigates the temperature change when magnesium reacts with dilute H2SO4. He does 5 experiments. Experiment 1, he uses a 25 centimeter cube measuring cylinder to pour 20 centimeter cube of dilute sulfuric acid into a boiling tube. Use a thermometer to measure the initial temperature of the acid in the boiling tube. Record the initial temperature. Add a coiled 5 centimeter length of magnesium ribbon to the acid in the boiling tube. At the same time, start a timer. Continually stir the contents of the boiling tube using the thermometer. After 45 seconds, measure the temperature of the mixture in the boiling tube. Record the temperature. Rinse the boiling tube with distilled water. Now, in case you guys are not familiar with a boiling tube, this is a boiling tube in which you heat it at the base and it gets hot, and it's basically made up of really nice material that can withstand high temperature. So yeah, So in experiment 2, this guy he uses the 25 centimeter cube measuring cylinder, pour 20 centimeter cube of H2SO4 dilute into the boiling tube, and now he uses a 10 centimeter cube measuring cylinder to add 2 centimeter cube of distilled water to the acid in the boiling tube. Place a bung in the boiling tube and invert the tube to mix the acid and water, and then record the initial temperature of the contents. Add 5 centimeter cube length of magnesium ribbon to the contents, and now measure the final. Now stir, and then measure the temperature of the mixture. Rinse the boiling tube with distilled water. So what he did was that he used dilute sulfuric acid in this one, but he diluted in this experiment even more by adding 10 centimeter cube. By adding 2 centimeter cube of distilled water to the acid. Now he repeated this experiment 3, 4, and 5 by adding more and more quantities of distilled water. Instead of 2, he used 4, and then 6, and then 10. So he increased the quantity of water. Use the information in the description of the experiment and the thermometer diagram to complete table 2.1. Volume of dilute sulfuric acid. So volume of dilute sulfuric acid we've been given in this one. He poured 20 centimeter cube of the. So we're gonna write 20 centimeter cube in this column.